Okay, so we are going to look at another example of an expression that is of quadratic type that we're going to solve. So remember, this is where we see something that looks like a w squared plus b w plus c equals 0. So it's going to have kind of the format of a quadratic. And so what we're going to do is a little substitution to help us see how we can either use the quadratic formula or factoring to approach the problem. And then we're going to try and solve it. So in this first example, it looks like we have 1 over t minus 1 squared plus 5 over t minus 1 plus 6 equals 0. And notice that this first term we can think of as 1 over t minus 1 squared plus 5 times 1 over t minus 1 plus 6 equals 0. Okay. So our term 1 over t minus 1 is being squared in the first part and multiplied by 5 in the second. So this is going to be our w, our substitution. We're going to let w equal 1 over t minus 1. And so this looks like w squared plus 5w plus 6 equals 0. And now we're going to factor this. So we get w plus 2 times w plus 3 equals 0. Because we wanted two numbers that multiply to 6 and add up to give us 5. So w plus 2 is 0, or w plus 3 is 0. And so we have two possible values. Either w is -2 or w is -3. But remember that w was a stand-in for 1 over t minus 1. So we have 1 over t minus 1 is -2, or 1 over t minus 1 is -3. Take a moment, pause the video, and see if you can find t. Okay, so you might have tried to do something like take reciprocals. So we could take the reciprocal of both sides, and we get that t minus 1 is equal to -1/2 in the first case, and t minus 1 is equal to -1/3 in the second case. Next, we're going to add 1 to both sides. And so we have 1 minus 1/2, or 1/2. And then adding 1 to both sides here, we have t equals 1 minus 1/3, or 2/3. Okay. And so these are our solutions. So let's look at another example. Okay, next up, we're going to look at x to the 4th plus 3x squared minus 5 equals 0. So this has that same format where we see a term, x squared, and we also see the square of that term. So that's going to be a good sign that doing a substitution and treating it as if it was a quadratic is going to be a useful tool here. So if we let w be equal to x squared, then this expression simplifies down to just being w squared plus 3w minus 5 equals 0. So this is this new expression is quadratic, and we can look for its roots. One thing to keep in mind is that although factoring is a very useful tool, it's not the only tool we have at the moment. We could also use the quadratic formula. We can also use completing the square. Because I don't see an easy factorization right off the bat, I'm going to try using the quadratic formula. So I'm going to write down my solutions. They're given by -b, so -3 plus or minus the square root of 3 squared, or 9, minus 4 times a, which is 1, times c, which is -5, all divided by 2 times a. And this simplifies down to being -3 plus or minus the square root of 9 plus 20, all divided by 2. Or -3 plus or minus the square root of 29 over 2. Okay. And this was what my x squared was equal to. So this tells me what my solutions are in terms of w, but not in terms of x yet. Okay. So we actually have two different equations. We have x squared is -3 plus square root of 29 over 2 that we want to solve. And we also have x squared equals -3 minus square root of 29 over 2. Now, if we look at this first expression, -3 is going to be, 3 is a smaller number than square root of 29. So square root of 29 minus 3 is positive. We have two solutions here. X is plus or minus the square root of our expression. So we undo this square by taking the square root of both sides. Okay, so we're using that square root property. We see these two different solutions. They're messy, but we've got them. If we look at our second term, x squared equals -3 minus square root of 29, all divided by 2. This has no real solutions because we have a square equal to a negative number. But if we wanted to write down imaginary solutions, we'll have x is the square root of 3 plus the square root of 29, all divided by 2 with an I outside. Okay. So the tools that we had previously for solving quadratic equations can still be used even if we're looking at expressions that aren't exactly quadratic. Great.